Hello, welcome to MSA 2020. This is the Data Science Pathway, and my name is Ben. And now you've probably heard of this before many times, but data is all around us. And as technology advances, the amount of data generated will increase more and more. And as useful as data is by itself, if we apply some data science technique over them, we can get more valuable insights, and these will eventually be used to drive business decisions. And I'll just quickly explain what data science is all about. It's best represented by the Venn diagram you see there. There's three main components to it: maths and stats, computer science, and business domain knowledge. Now, mathematics and stats is quite important because a lot of data science algorithms, for example, uses linear algebra to represent knowledge in a way which the computer can understand. So an example of that is neural networks. You might want to give a neural network an image of a cat, and then the neural network will tell you, whether there's a cat or a dog, and try to identify the image. Now, the neural network can't take in the image of a cat as an input, right? It needs to represent it in a matrix of numbers, and that's an example of the use of linear algebra in data science algorithms. Now, computer science is an important part of data science because in order to use any of these algorithms, you need to write some code. And if you want to build any algorithms, you will also need to build it using code. So it's an integral part. Business domain knowledge is also very important because, in essence, in the end, what we want to do is recommend business changes and help drive business decisions. And if we don't know what the business is about, then it's very hard to make useful recommendations. So it's pretty crucial to have some knowledge of the business domain as part of the whole data science process. Now I have a rough sketch of the data science life cycle listed as 4 bullet points. The first one is data capture. So this is basically gathering data. So you might gather data by web scraping, or you might gather data by extracting data from a database, or you can also gather data by extracting data from some front of house sales software. For example, a lot of customer details are scattered all over the place in some of those sales software, and extracting that information can be considered as part of data capture. Data maintenance is basically organizing the data into data warehouses and databases. Is usually maintained by data engineers, but data scientists really need to know how it works as well. Analyze. So this is basically analyzing the data, right? We're trying to look for trends or patterns and try to get as much value from the data as possible using some form of data science technique. And communicate is also an important part and sometimes overlooked part because the information and value you derived from the data, you need to communicate it to stakeholders and maybe the management or whoever needs it to make some business changes. So that's usually an overlooked part, but it's also an integral part. So we're going to teach you, we're going to dive a little bit into machine learning in phase 1, so I might as well explain a little bit more about it here. It's basically an algorithm, right? And how this algorithm works is it minimizes the cost function. Okay, so that already sounds quite complex, but it's very straightforward. If you just look at the diagram there, right? The cost function is basically the distance from each of the points from the line. So in order to minimize this the distance between each of the points and the line. If we minimize that, then the algorithm can come to a solution, and the solution is the line of best fit. And what the line of best fit does is basically, it identifies the trend in the data. It finds the pattern, and then using this trend and pattern, the algorithm can make some predictions given future inputs or future data points. So this is the outline of this phase one program, really. So we're going to build up the data set. So that is part of the data capture process. And we're going to do it by using API call and also web scraping. Although web scraping is not a compulsory part of this program, I've included a very comprehensive tutorials on how to do it, and I will be quite happy if you guys do have a watch of that tutorial. I think I have 2 examples of web scraping uploaded onto GitHub, so please have a look. After the dataset building part, we move on to the data analysis part, and that's basically first starts off with data cleaning, and that's a very important part that you have to carry out before analyzing anything, because if the data is not clean enough, that can lead to false results, or the algorithm may not work as well as you want it to. So what data cleaning mainly involves is things like looking at null values, looking at outliers, and looking at impossible values. For example, if there's a land area of a house and the land area is -1 million, then that value is considered impossible, right? And then we explore the relationships between some of the variables. So we want to see how the variables relate to each other, and mainly we just want to have a look at the spread of each of the attributes and some basic statistics about each of the attributes. For example, the mean, the minimum, the maximum. That will already give us a pretty good insight into what the data looks like. And finally, we will do some model building. In phase one, you are probably just going to do linear regression. Actually, no, we expect that you will just be doing linear regression. Obviously, we can move on to more difficult stuff later on, but linear regression is a very good starting point for machine learning. That's all from me. Hope you guys do enjoy the phase one part of MSA in this pathway, because we actually spent a lot of time building this, and all the best. Hello, welcome to